Hello everyone, good evening.
Good evening, sir.
Evening, sir.
Good evening, sir.
Okay, so today we have revision session for week 11 and 12. So, did all of you attended week 9, 10 revision session as well, or there are some who haven't gone through the 9, 10 revision session and directly coming there?
Attended, sir.
Attended, right?
Yes,
Because I
certainly.
will be continuing from the things which we have discussed in 10 sessions. Okay, so in week 11, we have mainly covered binomial distribution. Which is,
Sorry, sir, but I think there is some noise.
So your
some
voice
noise.
is not very clear.
Not okay. Okay. Is it clear now?
Yes.
Hello. Is it clear now?
No, sir.
So clear, sir. Just some comments.
Is it clear now? Hello.
Yes, sir.
So audio is clear to everyone now, right?
Yes, sir, but there's some little disturbance, so it doesn't matter, I guess.
Understood. Okay.
I think some mic issue would be there, sir, if you can check.
Sir, your voice is not
Okay. Is it clear now?
Yes, sir. No, it is.
Yes, sir, clear.
Okay.
Sir,
So yeah.
excuse me, sir. One request. Hello.
Yeah. Yeah.
Can you, from your end, sort out the CT mock because it is scheduled at 9:30, I guess. 9 to
9:30.
10:15. 9 to 10:15 between this session. So can you just shift it like previous time?
9:30 to 10:15. Okay.
No, it's 9 to 10.
9 to 10. Okay. Okay.
Hello, sir. I joined a bit late because we had another session for maths revision. So, what all you have covered, sir?
We haven't started yet. We are about to start.
Okay, sir. Thank you.
Okay. So CT session you wanted to shift, right?
So not session,
Yes, sir.
some mock
CT
test.
mock, sir.
CT mock, yeah.
Hello, is it audible?
Yeah. Yes, it is audible.
Yes, sir. It is audible.
Okay, so CT mock will be shifted. Okay, so let's start with week 11. So week 11 mainly focuses on binomial distribution. Okay. So do you are now aware of what is random experiment, what is random variable, right?
Yes, sir.
Okay. So
Sir, just one song request, sir. Sir, just can you please explain little bit first about Bernoulli? Means there is a confusion. Means what is the Bernoulli distribution and what is binomial?
yeah, for binomial we have to start with Bernoulli.
Okay, okay, sir.
Every discrete distribution you will be studying, you have to, like, Bernoulli will be involved in some sense in that.
So, sir, both are related, right?
Yeah, both are
Bernoulli
related.
and binomial. Yes. Okay.
Yeah, every discrete distribution in some sense will be related to Bernoulli only. So in this course, like, you are not studying much of distributions, but yeah, as soon you cover more distribution, you will see there is some relation with Bernoulli, each distribution having. Okay, so yeah. Okay, suppose you're doing an experiment, okay? You're doing a random experiment. Okay. And you are doing it only once, okay? Like you are tossing a coin, rolling a die, or anything, right? And you suppose you predicted something or you want something to happen. Like if you're tossing a coin, suppose you wanted it to be heads. Suppose if you are rolling a die, you wanted it to be an even number. Okay. Such things could be are of major interest for us. Suppose if you're playing a game of Ludo, you wanted to have a 6 in your first roll of a die, right? So these things are kind of like an success for you, right? Something that you have achieved. Like if you wanted head and it's come out to be an head, it's some kind of an achievement, right? You wanted an even number, it's also a success for you in some sense. And you wanted a 6 in a roll of a die, it's also a success for you in some sense, right? And all other outcomes, like if you are tossing a coin, your possible outcomes are only head and tail. If getting a head is success, then the remaining, if you get any other thing than heads, it would be a failure for you, right? Similarly, in roll of a die, if getting an even number is success, then getting an odd number would be a failure for you, right? Are you getting this thing?
Yes, sir.
Okay, so if you are rolling a die, you wanted 6 to be on the first throw of a die, but if you get any other number of 1, 2, 3, 4, 5, it's kind of a failure for you. Okay? So whenever you can, split your sample space into two parts, one portion representing success, one portion representing failure. So generally those distributions are called Bernoulli distributions.
So that means only whenever two possibilities are there, binomial with Bernoulli will be there, failure or success.
Yeah, failure or success. You can define success to be anything and remaining goes to the failure. Like, even though in rolling a die, there are 6 possible outcomes, right? But I can still split it into even and odd, and I am dividing my complete sample space into two parts, that is success and failure. So whenever you are able to divide your sample space into two parts, in some sense, it would be a Bernoulli distribution. So suppose X is a random variable, right? And it takes the value 1, like it will increase the count of my success by 1 if I get the success, and say with probability p, where p is probability of success. And if I didn't get the success, obviously the count of success would not increase, it would remain same, 0. And the probability of failure would be 1 minus p, right? Because if for success it's p, the remaining thing goes to the failure. And we know sum of the probability should be 1. So it would be 1 minus p. Is it clear till this step? Or any doubt?
Yes, sir, it is clear.
Yes, sir.
Okay. So yeah. So this random variable x is said to be follow Bernoulli distribution. This random variable x follows Bernoulli distribution. So what are the major points for Bernoulli distribution is you are able to divide your sample space into two parts. One is success and one is failure. Okay? And whenever you get success, your count of success get increased by 1. And if you're not getting a success, it will remain 0. And you have some probability of success and failure. Like if you're tossing a fair coin, then here your probability of success would be 1 by 2. And for failure also it would be 1 by 2. And if you're rolling a fair die, then in case of this, your success probability would be 1 by 6. And for failure, it would be 5 by 6. In a way or other, you can identify Bernoulli distribution kind of easily. Now, what happens if I keep on, like here I'm doing it only once, right? But it's possible for me to do it again and again and again, right? I can toss a coin 10 times, 20 times, 50 times. We can do it in general n number of times, right? I can repeat this experiment n times, right? Okay, so one interesting thing to know is if I toss a coin, if I toss a fair coin, right? In each trial, suppose I'm talking about this experiment for now, where getting a head is my success and getting a tail is failure. In each trial, you see that the probability of success is same for me, right? It's not changing. It would always be half in each toss of a coin, right? P remains same. Okay. And we also know the number of times I'm tossing a coin, or we are performing the experiment. And we know it is n times. So we are aware of two things over here. One is that my probability of success is remains the same for each trial. Secondly, we know how many times we are going to do it. Like I know I'm going to toss the coin 10 times. And in each toss, my probability of success remains the same. And also, one more thing if you notice is, each toss is independent of each other, right? Each toss of a coin is independent of each other. Because if I get a head in my first toss, it is in no sense affecting the probability of getting heads in the second toss, right? So each toss is independent. So whenever you keep on performing Bernoulli trials, right? When you're doing it one time, it is called one Bernoulli trial. If you keep on doing it n times, okay, and these conditions are satisfied. Condition 1, that your probability of success remains the same. Condition 2, you know that you are going to perform the experiment n number of times, or whatever be the number, you can do it 100 times, 1000 times, but you know that we are going to do it that many times. And third, and the most important thing is that none of my trial is dependent on each other. No trial is affecting any of my other trials, right? Each of the trial is independent. So in general, if I add these, like suppose this is my first trial result, this is my second trial result, and so on, this is my nth trial result. And in each trial, these conditions are satisfied. So we can say that this sum of Bernoulli trials, which are satisfying these three conditions, follows binomial distribution. Is this thing clear? How we are obtaining the relationship between Bernoulli and binomial?
Clear, sir.
Sir, please repeat, sir, this binomial
Yes, sir.
distribution.
Please
Sir.
repeat once time.
And sir, please mute everyone, sir. There is some background noise from someone.
Okay. Are these three conditions clear?
Yes, sir.
Three conditions clear, right? Okay.
Sir, one thing for second point, number of times we are performing the experiment n. So for each n, there will be separate probability which does not depend on means another term, right?
Yeah, for each trial, we have the same probability. Same probability
Sorry,
of
sir?
success P. For each trial, the probability of success is same. It's P.
Okay, sorry.
Okay, because the second condition is, it's only that I'm repeating the experiment n times, but at the same time, my first condition should also be satisfied, right? The probability of success remains the same.
So some noises coming.
Okay.
And excuse me, sir.
Hello. Hello.
Yes, sir, it's hello.
Yeah, please.
And sir, what about the sum that is equal to 1? The probability is equal to 1.
Probability equals to 1. Okay, so you know that if you add up the probability for each of the possible outcome, like if you add up the probability, take the probability of sample space, it's 1, right?
Hmm.
So now I have divided my sample space into two parts, success and failure, right? So if for success the probability is P, then for failure it must be 1 minus P, right?
Yes. No, I'm telling if that is also the case for binomial Bernoulli distribution, no, this should also satisfy.
Yeah, it's the basic probability rule, right? The sum of
Yeah.
probability should be 1. So
Yes.
basic probability rules would be followed always. Okay. Okay. So yeah.
Sir, so in binomial distribution, which you are mentioning, like x1, x2, so that distribution is like you are taking the success or failure. It is both, like you're combining x1 plus
Okay.
x2.
Yeah, I'm coming to it. Okay. So these three conditions are clear, right? For now.
Sir, for point number 2, it means that number of trial is not fixed.
Number of trials is fixed. We know that we are going to do it n times.
Oh, okay.
Okay. If it's not fixed, then you cannot, go to binomial distribution.
Then yeah, binomial experiment is not satisfied.
Yeah. Okay. So. Okay. Suppose I am doing the Bernoulli trials. I keep on doing it n times. Okay. So how many number of successes I get?
N.
Suppose x1 is the result of first trial. Okay. x2 is the result of second trial. x3 is the result of third trial, and so on. xn is the result of nth trial. Okay. Now you notice whenever I get a success, I will get a value of 1, and whenever I get a failure, I will get a value of 0, right? So in general, if I add all this, I will get the number of successes I have got in n trials.
Yes.
Suppose my n equals 3. Okay? And so in general, suppose x1, x2, x3. I got the success in x1 first trial, so x1 will take the value 1. I got the failure in the second trial, so x2 will take the value 0. And suppose I got the success again in the third trial. So number of successes which I got is just the sum of these, right? 2 successes I got. Right? This is
Yes.
nothing but number of successes. Is this thing clear to everyone?
Yes, sir.
Yes, sir.
Okay. So see, each
So
xi is my Bernoulli trial, right? It's, each xi represent the result of Bernoulli trial. You can say each xi is a Bernoulli random variable. And if I sum n of these Bernoulli trials such that these three conditions are satisfied, then this number of successes I can denote it by another random variable x. It follows binomial distribution. Okay, with parameters n, and where n is your number of trials, and p is the common probability of success for each of the trial. Is this thing clear to everyone?
yeah,
How
sir.
we are
So
writing? Yeah.
one doubt, sir. So when we are adding it x1, x2, so there the failure is also included, right, sir? So my question
Yeah,
was like,
for failure it's 0, right?
yeah,
So
sir.
it
But
won't affect my sum. Yeah, go ahead.
yeah, but that x, when we are adding all this distribution, then it will be combining, like it will be again the total probability, right, sir?
Not total probability, right? I'm combining the result of each of the trial. I'm not combining all the possibilities. Like if you notice for x1 your possibilities are 0, 1, right? For x2 it's 0, 1 again, x3 it's 0, 1 again. I'm not combining all of them. I'm just combining the result which I got. For first trial I got the success, I will keep only one. I will not keep other possibilities. If for x2 I got failure, I will keep 0 only. I will not keep 1. Similarly, I will keep only the result of each of my trial. And we are not
Sir,
taking
I
all
have
the
one more doubt,
possibilities into
sir.
consideration. Yeah.
Sir, here you are assuming the value 1 and 0, 1 for success and 0 for failure. But
Yeah.
sometimes we have with the points also 0.6, 0.4 like that also, no, sir. So if we add x1, x2, x3 together, then the failure is also included in that, no, sir.
Yeah. So you can go from Bernoulli to binomial only when you represent Bernoulli distribution like this. And this is the general Bernoulli distribution. General binomial, Bernoulli random variable, you can say.
Okay. So if we have 0.6, 0.4, then we shouldn't consider that as a Bernoulli distribution, sir.
Yeah, you shouldn't.
Okay. Okay, sir.
Okay. Is this thing clear how we are arriving at binomial from Bernoulli? Or any doubt in this, anyone?
So we are considering only the success part, right? So here x1, x2, x3, or we
Yeah,
are
if suppose
considering
if I add them all, right? If even if it's failure, it won't affect my sum. I'm interested in number of successes. Even if it's a failure, it won't affect my sum. At the end, I'm going to get the number of successes I have got, right? Because for failure, I will be denoted by 0 always.
Okay. But here, sir, in the trial, when you are mentioning, you are considering the successful probability, right, sir? The probability
Yeah.
which is having the severity, I can say, right, or
This one
success.
here. This part you are saying.
Sir, the P role will come into in that case when we want to check the success probability, right? Here, in case of number of success means it's a random variable. It's a variable, right? It's not a
It's a random
probability
variable.
of success,
No,
right,
it's
sir?
your random variable is number of successes here for
Yes, sir.
binomial. Yeah.
Yes,
How
sir.
many successes you are getting in these n trials? Where these n trials satisfy these three conditions.
Suppose if you want to get the probability of success, a number of successes out of total n.
Yeah. Where these conditions are satisfied. Your probability of success is same for each trial, and each trial is independent of each other, and you know how many times you're performing. Yeah, you can use binomial distribution to identify.
Okay.
Any doubt till now, anyone? Shall we proceed further?
Yes, sir. You can proceed.
Okay. So till now, okay. So if it's Bernoulli, right? We know it's for probability of success, like it's P, for probability of failure, it's 1 minus P. So I know that my x1 will take the value 0 with probability 1 minus P, x1 will take the value 1, P, right? So in some sense, the PMF is defined for Bernoulli, right? X, its probability, it will take value 0, 1, right? So PMF is defined for Bernoulli, but how will we do it for binomial now? So here you again need to recall some concept of permutation combination. Let's see. So your X say denote number of successes in n independent and identically distributed Bernoulli trials. Okay. So recall what is your number of successes? Okay. Now suppose I am interested in suppose say getting take any number. So now let's say 5 successes I am interested in. Okay. And suppose for now it's 10. So how will you find the probability of 5 successes in 10 trials? Okay. So that's the major concept, right? That would be the PMF for binomial distribution. It tells us the number of successes in some n IID Bernoulli trials. So I must be able to compute like in how many, what are the chances of getting this many success in n number of trials, right? So anyone, how will we get? How can we obtain? Okay, in how many ways I can get 5 successes in 10 trials? Forget
NC5.
about the probability.
NCX formula, sir.
NC5.
NC5.
Intensify, right? So intensify ways I can get 5 successes in any of these 10, right? Okay. So what are the chances of success? P, right?
P
It's
raised to
same for
5.
each trial, right? So for 5 successes, it would be
E raised to
P
5.
times P times P is to for 5, right? And also I need 5 failures. So it would be
1 minus P
1
raised
minus
to power
P.
5.
So it is the probability that my random variable takes the value, like my binomial random variable takes the value 5. Now let's generalize it. Okay. Now you're aware of this, so let's generalize. Okay. So what is the probability that my random variable x will take the value small x, let's say? It means in n trials I need x successes, right? So in how many ways can I get x successes in n
NCX.
trials?
NCX.
NCX. And
E
for
raised to
x,
X.
like for
E
each
raised
success, the probability is p, right? And I need to get x of it, and
1
remaining I
minus
need to
P.
get the
N minus X.
value, right? So it is nothing but your PMF for binomial random variable. Few things to keep in. What all possible values your x can take here? I can have 0 successes, 1 success, 2 success,
3,
so
4,
on
5.
up to
Up to n.
0 up to n.
it cannot go beyond n, right? And it cannot go below 0 as well. Minimum I can have is 0, maximum we can have is all successes, right? So even if you put n equals 1 here, you will obtain Bernoulli back, because your if n equals 1 means you are doing only one Bernoulli trial, right? So you must obtain Bernoulli distribution. So it would be 1 cx, right? And p raised to the power x, 1 minus p raised to the power 1 minus x. So if you notice you have 1 cx, it's nothing but 1 only, right? Either it would be 1c0 or 1c1. So it would be 1 in both the cases. And if you put x equals 0, so probability x equals 0 means p raised to the power 0, 1 minus p raised to the power 1 minus 0, you get the same result, right? Similarly, for x equal to 1, you will get the same. So It's binomial in some sense in related to Bernoulli. If you even in binomial, if you put n equals 1, you will again get Bernoulli. Is this thing clear to everyone? Or any doubt in this?
Sir,
Yeah.
sir, n equal to 1 means Bernoulli or n equal to 2 or more means binomial.
See, n equal to 1 means you are performing only one Bernoulli trial, right? One
Yes.
Bernoulli trial means it is known binomial distribution only, right? And if I do keep on repeating the Bernoulli trials like more than one time, it will shift to binomial distribution, assuming it satisfies those three conditions, right?
Yes.
Sir, can you explain here like P5 and 1 minus P5, like it is for each trial, right? Or it is like
Okay. Okay, let's make it a bit smaller and be large. Okay, suppose we have five trials. Okay, one, two, three, four, five. Okay, n equals 5, and let's say probability of success. Let's say it's 0.3. So probability of failure would be 0.7, right? Suppose I am interested in that I will get three successes in these five. So in home, three successes of the five, it means in some sense you have three yes, right? Three successes, and remaining two you have a failure, right? So let's make it success one, success two, or success three, or something like this. You can assume. So in how many ways can you get three successes of these five?
5C3, sir.
5C3 ways, right? Because you can you like you can take any three of these five to be your successes, right? And it order doesn't matter here, like in
Yeah.
which order you are getting these successes. So it's combination
Yeah.
5C3, right? Now suppose the three I selected are this position, and this position, right? Now we also need to take into consideration the chances. Like if I'm getting success here, its chances are get p only, right? Probability of success of 0.3, right? Similarly,
Yes.
for this success, the chances are 0.3, for it also it's 0.3. And for remaining, it's 0.7 and 0.7, right? So we need to take into account the chances of these three successes, which is nothing but PQ, right? P into P into P. And for remaining, you also need to take into consideration the chances of failures. So first, what we are doing is we are fixing three places where I am getting successes, and then we are assigning the chances of getting success over there and failure over there. So it's something going like that. Are you able to visualize it, like how it's going?
Yes, sir.
Does this give a probability or frequency?
It's a
I mean,
probability, right?
so computing this, it will give us a number or I mean, what is the probability of these three being success, right? Or
Yeah, it means the chances of getting three successes in five trials. The probability of getting three successes in five trials.
Sir, does this also give the probability mass function as well?
Yeah, it's the probability mass function, right? So we generalize it for n, right? In n trials, you need to get x successes. And your x can take value from 0 to n,
0 to
right?
n.
So you can put in the value from 0 to n, you will get the PMF, right? So your PMF would be something like this. You can take value 0, 1, 2, 2n. For probability x equals 0, just put in 0 in this formula. For 1, put in 1 in this formula. For 2, put 2. And so on. For n, put n. You will get respective probabilities, right? So in general, we are generalizing the formula for PMF.
How to solve the most uncertain Bernoulli trial?
Most uncertain. Okay, we'll come to that as well. Is this thing clear till now? Like how we are going from Bernoulli to binomial?
Yes, sir.
Or
Yes,
any
sir.
doubt in this?
Clear, clear.
Clear, right? Okay. So just a quick question. Suppose in a bag there are 10 red balls. Okay.
Sir, there's some background noise. Can you please mute it?
It's from outside, I think. I don't know, some event going on. Loudspeakers. I've tried to make it as minimal as possible for the next cell coming. Okay, so suppose in a bag there are 10 red balls and 5 blue balls. Okay, and suppose I'm drawing one ball and I'm interested in getting a red ball. So what distribution is it?
Binomial distribution?
Hypergeometric.
Hypergeometric, yeah. 10 C1, yeah.
So can you please again tell the question?
Okay, in a bag there are 10 red balls, 5 blue balls, and I'm drawing one ball of it. And my x denotes the number of red balls. So what distribution my x follows?
So
You are drawing without replacement?
I'm drawing only one ball without doesn't matter, right?
Then Bernoulli we can.
Okay.
No, sir.
Bernoulli, sir.
Hypergeometric.
Binomial.
Hypergeometric.
Hypergeometric. Okay.
Hypergeometric with replacement.
Okay. So all three are correct for now. Okay. So those who are saying Bernoulli, right? So for Bernoulli, let's say your probability of success would be 10/15, right?
Yes, sir.
So chances of getting one red ball would be 10/15 and getting 0 red balls would be 5/15, right? For Bernoulli. Okay, so 1 minute. Okay, those who said binomial.
There's a catch for binomial and hypergeometric. Like for hypergeometric, it should happen with without replacement, and with replacement for binomial, right, sir?
Yeah, but in this case, binomial is also true because you are doing it only one time, right? It doesn't
Okay,
matter if
yeah.
replacement or replacement.
Okay.
For those who said binomial, n is equals to 1, right? Probability of success, it's only one trial, so like it's gonna remain the same. There is no other trial. So whatever be the probability of success here, it is the only success we have. 10/15, right? So x equals 0 means 1C0, right? 10/15 raised to the power 0. 1 minus 10/15 raised to the power 1. Which is nothing but 5/15, right? And similarly for x equals 1, it would be 10/15. So for Bernoulli, those who said are also correct. Binomial, it's also correct. And some said hypergeometric as well, right? It's only one trial, it doesn't matter whether I'm doing with replacement without replacement. Hypergeometric is also correct in this case. Okay, because since I'm drawing only one ball, right? So if you know the formula for hypergeometric, so out of 10 I choose 0, out of 5 I choose 1, and in general I'm choosing one of these 15, so it's again 5/15 for x equals 0. For x equals 1, it's 10/15. Okay, so it doesn't matter which distribution you choose, Bernoulli, binomial, hypergeometric, you're gonna get the same answer if you're drawing only one ball. Okay, now let me modify the question a bit. Suppose I'm drawing 5 balls now, and I'm doing it with replacement. What distribution would it be now?
Binomial.
Binomial.
Binomial. Okay, so why binomial?
The events are independent
Finite number of trials.
equal.
And each trial is identical.
Yeah, So probability of success remains the same, right? Number of trials, we know it's gonna be 5, and trials are independent as well, right? What if I'm doing it without replacement? What would be the distribution in that case?
Hypergeometric.
Hypergeometric, right?
Hypergeometric.
Because your probability keeps on changing, and you are able to divide your sample space into two sections, right? Your interest is in this one and others, right? Red and non-red, you can say, and you can proceed. So, see, everything starts from Bernoulli distribution, right? You have one Bernoulli trials. It depends. If you do keep on doing it with replacement, it will convert to binomial. If you keep on doing it without replacement, it will convert to hypergeometric. So every distribution you're going to study in some sense it's related to Bernoulli. So is this thing clear? Or any doubt in this, anyone?
So please explain how it is hypergeometric when without replacement.
Without, okay, do you know what is hypergeometric distribution?
Yes, sir.
What is it?
Divided into two categories.
Yeah.
One category is 10 red balls and there is 5 blue balls.
Okay, then what are the conditions for hypergeometric distribution?
Or we can say, so choosing n sample out of B population.
Okay. Okay, so in hypergeometric, what happens is, suppose you are able to divide your sample space into two parts. One category is of interest, like your interest in red ball, and the remaining goes to the category 2. And we wanted to know, like, if I am say here drawing the ball 5 times, right, without replacement, then how many red balls would be there, like how many balls which I am interested in would be there. So for that we use hypergeometric distribution. So here these conditions are satisfied. I am able to divide my complete sample space into two parts, and after that I am doing it without replacement, so it is hypergeometric distribution. And it won't be binomial because the probability of success will keep on changing after every trial, right? If in the first trial red ball is drawn, then in the second trial I will be left with only 9 red and 5 blue. So probability of success will become 9 by 14. It will no longer be 10 by 15. So it keeps on changing. Whenever you are doing it without replacement, it gets shifted to hypergeometric, and in case of the replacement, it might get converted to binomial. Is this clear to everyone?
Yes.
So, sir, suppose in exam, such type of question occurs with replacement. So can we solve it directly by binomial formula?
If the conditions are satisfied, you can.
Okay, means probabilities are same for each and every trial. NR we have fixed, and they are independent. So we can directly apply the formula for binomial. And for hypergeometric, so we have to check the without replacement, but there is no such mandate of these 3 conditions for hypergeometric, right?
Yeah.
Okay. Sir, but in case of means we have whole 12 weeks of course, right? So how to distinguish with whether it is from 5 to 8 question or whether it is from week to 9 regarding this ball choosing?
Regarding this ball choosing, okay.
Means this type of questions, sir. How to distinguish?
See, I have already told you, whatever you have studied in week 1 to 8, it's the same thing we are going to do in week 9 to 12. We are just using random variables to solve the same. You have already done this question, right? There are 10 red, 5 blue, how to draw, right? You know, week 7, you have already did such question. In week 11, again, we are doing, but this time we are using random variable and Bernoulli distribution to solve this. So it's the same thing we are doing. So it's up to you when to consider it week 7 or week 11, but yeah, in general, you can do it either way. It's the same one and the same thing.
Sir, one request, sir. Like Microsoft Teams, we can minimize the background noise. So, do you know, means in Zoom, can we minimize it?
Okay, so yeah, it's from my end. I think this background noise.
Yes, sir.
Right.
A lot of noise songs. I don't
Not
know
songs.
from where it is.
I think there is a temple nearby his house, and they're playing Mataji songs. If I'm not wrong,
Yeah, something like that. Yeah.
Maybe.
I know those songs. So
Okay. Okay. Just wait a minute. I will try to search.
Because in Microsoft Teams, it has a great performance to cancel the noise. There is one setting.
the setting is there in Zoom as well.
But I don't know about Zoom. They should have such type of feature in Zoom.
In the desktop client, you should click settings, and in the audio tab, there is
Suppress high background.
yeah, there is an option. Yeah, suppress background noise section.
Hi everyone. Can anyone just summarize what Sar said now, please? No one.
Is it clear now? I think a bit less noise from now.
Yes, sir, it is clear now. But the CT mock test, we just got one more reminder that it is in next 20 minutes.
Okay, give me a minute. So that
Thank you.
Okay, so it will get either extended or shifted. Don't worry about that. We will have enough
Okay.
time.
Yeah. Thank you, sir.
Okay, so any doubt till now, anyone?
So please can you explain it once again, sir, how we can define hypergeometric or binomial from a Bernoulli?
Hypergeometric and okay. So you understood till now, like how, like what are the conditions for
Sir,
binomial distribution?
I'm unable to visualize that, sir, with replacement, without replacement, that thing.
Unable to visualize?
With replacement and without replacement.
Okay, let's work on the visualization part. Okay. Uh, Suppose there is a box of balls you have, okay, and you have some 10 red balls and 5 blue balls.
Okay,
Right?
sir. Okay, sir.
Okay. Now I'm doing it with replacement. So let's say I'm doing it only 2 times from now. Okay. So in the first try, what is my probability of, like suppose I'm interested in red balls.
It will be
What is the
10 by
probability
15,
of
sir.
drawing 10 by 15? Yeah. In the second trial,
With replacement, it would be the same, sir.
with replacement, we are doing same, right? 10 by 15.
Right, sir. Right, sir.
Okay. So probability of success remains the same in both the trials. Do we know how many times we are doing? Yeah, we know that we are doing it 2 times, right?
Okay, sir.
And you see that uh, there is the result of my second trial is no way, you know, dependent on
It
what
depends on
I
the
draw in
first trial.
first trial. Yeah, it is independent, right? Both trials are independent.
Right, sir.
So the three conditions of this Bernoulli trials are like satisfied, right? This is
Yes,
first
sir.
Bernoulli trial. This is your second Bernoulli trial.
Okay, sir.
In both the trials, probability of success
He's
remains the
getting a red
same.
ball, right? Sir? 10 by. Okay, sir.
So your number of successes is the success if you got in the first trial or success you got in the second trial. So we know Bernoulli is defined as this, right? 1 and 0. 1 if you get success, 0 if you get failure.
Yes, sir.
So number of successes which I get can be written as x1 plus x2, because if I get suppose success in first trial and failure in second, so in total I got only one success, right?
Yes, sir.
If I got success in both, so I got two successes. So I am able to write the number of successes in two trials as the sum of these two, right?
Yes, sir.
So this number of successes is my binomial distribution. But suppose now you're doing it without replacement.
Okay, sir.
Okay. So in the first trial, the probability would be 10 by 15, right? For the second, it depends
Yes, sir.
whether the first ball drawn is red or blue, right?
Blue.
So
Right, sir.
P is not remaining the same for each Bernoulli trial, so its kind of condition gets violated, right?
Yes, sir.
But to save us, we have another distribution called Hypergeometric distribution. So we are able to divide our complete population into two parts. One is red ball and other is blue balls, right?
Right, sir.
And we are drawing without replacement. So whenever we are able to do it, we divide the complete population into two parts and draw without replacement. Then number
Okay,
of
sir.
like red balls, right? It will follow hypergeometric distribution.
Right, sir.
So that's how we can distinguish between them.
Right,
Is
sir.
it clear
Got the
now?
points. Thank you. Yes, sir. Yes, sir. Thank you, sir.
Okay, so yeah, let's move to the expected value of binomial distribution where x follows binomial. N is the number of trials, P is the probability of success. So, what is the formula for expectation of a random variable?
NP.
NP, sir.
No, not for
NP.
binomial. Random variable, any random variable.
A plus B by 2.
It is summing all value over all values of x times probability, right?
Yes, sir.
Yes.
NP.
You can plug in the value. I'm not going into the proof for now. Okay, if you solve it, you will get n times p. Okay. How to verify it? Like, we don't want to go into this complex calculation, but still we want to verify our answer. Okay. So, okay, let's move to first Bernoulli. It's easy to compute, right? You take value 1 with probability p, 0 with 1 minus p. What is the expected value of this random variable? Bernoulli random variable.
P.
P, right?
P, sir.
Okay. Now recall, what is our binomial distribution? It is the sum of n Bernoulli random variables, right? An independent Bernoulli random variable. So its expectation would be, by using the property of expectation, I can write it like this, right? Which is nothing but p plus n times square n p. It is n times 1. So it's kind of get verified from here. Is this thing clear?
Yes, sir.
Sorry for the interruption, sir.
Yeah.
But sir, I think some statics from your mic is coming, sir.
Is it for everyone?
Yes, sir.
Yes, sir.
Yes.
Kind of white
Okay, but
noise and static, but yeah.
okay, but okay, thing. Okay, give me a minute.
So finally, the expected value of binomial is NP only. No? So
Yeah, it's NP only.
okay, thank you.
Okay, is it clear now?
So have
Yes, sir,
you
static.
suppressed
Okay,
your
sir.
background noise to low in the settings?
But we can hear, sir. You can continue.
Yes, sir.
Sir,
We
you
can hear. It's
continue,
clear
sir.
only, sir.
Continue, sir.
Can audible. It's audible, sir.
Okay, so is this thing clear? Like p plus p, how we can verify that? How we can verify
Yes,
that
clear,
expected
sir.
value for
Yes, sir.
binomial?
Yes, sir, clear, sir.
Let's move to variance. So variance of x, what's the formula? Do you all know it's expected value of x? You know, so we can also open it. So you can. We did this derivation in the last week 19 revision session. How we obtain this formula, but still computing this with it will require a lot of complex calculations. So how do we find variance of binomial distribution? So let's start with the Bernoulli. So what would be the variance of this random variable?
P into 1 minus
So
P.
p into 1 minus p. Okay, and how did you compute it? So
So
firstly,
Minus
yeah,
EX by square.
EX minus EX the overall whole square.
yes. Firstly, if I go by this formula, expected value of x square, it is summing over the all values of x squared times its probability, right? Those who don't know how we get this, refer week 9 10 revision session. We discuss it over here. Consider x square as a function of x. Okay. So if you do it, you will get again p, right? 1 square times p plus 0 square times 1 minus p, it's again p. So variance of x1 would be p minus, we know expected value of x is p, it's p squared, right? So it is p times 1 minus p. It is a variance of Bernoulli random variable, right? Is this thing clear or any doubt till now?
Clear.
Clear, sir.
Okay, so recall again your binomial is sum of n independent Bernoulli trials, right? So these all are independent, right? So recall the property of variance. If these all are independent, I can write it as variance of x1 plus variance of x2 plus so on variance of xn, right? So it is again adding p into 1 minus p n times p 1 minus p. So that's the variance of binomial random variable. Any doubt in this till now, anyone?
Clear, sir.
Yeah, right. Okay, so someone mentioned like most uncertain random variable, right? So what do you mean by most uncertain? When a random variable is most uncertain?
Maximum variance.
Yeah. So whenever variability is maximum, the random variable is said to be most uncertain. So in general, you need to maximize variance to find it. So if your random variable is say binomial, so variance of x would be n times p times 1 minus p. So number of trials is fixed. So it will be maximum when your p equals 1 by 2. So if you are asked when would your binomial random variable would be most uncertain, it is at p equals 1 over 2. Okay, is this thing clear?
There is one question where they have written the equations also from
Which equations?
Just a minute. Activity 11.1, question number 5.
Activity. Okay, let me share my screen.
Is it like x plus x by 10 greater than equals to 7?
Oh, no.
Okay, 11.1, right? Which question?
Last one.
This one, right? Fifth question, right?
So yes, sir, I have a doubt in that question.
Okay, so you see that your y is a Bernoulli trial, right? It takes the value 1 when you get some condition satisfied, otherwise it will take 0, right? So getting a value less than or equal to a is your success, and getting a value greater than a is your failure, right? So to maximize, like most uncertain Bernoulli trial means maximum variance. So its maximum would be like variance would be maximum when your probability of success is 1/2 or 0.5, right? So if I take a is equals to 3, suppose a is equals to 3, what would happen in that case? If I take a is equals to 3, so probability x less than equal to a would become 0.5, which means the probability of success of my Bernoulli trial, which is denoted by y, it is 0.5, and the probability of failure would also be 0.5, which will maximize my variance. So if I take a is equals to 3, it would be most uncertain Bernoulli trial. Is this thing clear?
No, sir. How do you get 0.5, sir?
If I take a is equals to 3,
Okay.
okay, then what would be the probability of success for y? Like when will y take the value 1? When is x
Success.
less than or equal to? Yeah, whenever x
X
is less than or equal to 3. What are the chances of getting x less than equal to 3?
1, 2, and 3.
0.2.
Yeah, but
0.2 plus 0.2 plus 0.1.
0.1, 0.2. Okay.
0.5, right? So if I take a as 3, then probability of success, or means probability of getting value 1, it's 0.5, and for 0, it's 0.5, which is failure, right? So it becomes most uncertain at a is equals to 3.
Okay, sir.
Okay, I think we are done with week 11. Any doubt in this things we have covered, or in week 11, anyone? Shall we move to week 12?
Can you just tell variance on this once more?
Variance of binomial.
Variance, yeah. But no.
Okay, variance of binomial.
Sir, one small request after this week 12, in tabular format, can you please write down all the important formulas and their relation? If
That's
time
what we are
permits.
discussing only, right?
No, sir, means just a glance. We are doing one by one, right? Means at the last, if the time permits.
Okay, so here what we are doing is we are trying to obtain the relationships only, right? So if you remember one, you will be able to recall each and every other. So if you want all formulas written, you can refer the textbook also, right? It's all written there. The reference textbook, weeks 7 to 12, we have shared, right? You can go through that. It's all written over there.
Week 0, right, sir? Week 0, no?
Yeah.
Book, okay.
Okay, so the variance part you are asking, right?
So that is shown as week 0, right? The book week 1.
It is actually, statistics to week 0 textbook it is, but it has all the content of week 7 to 12 of stats 1, and it also has some extra content which you can ignore.
So where is the textbook, sir?
Supplementary contents.
Right, thank you.
Okay, so okay. Suppose it is your Bernoulli trial, okay? the probability of success P and probability of failure 1 minus P. What would be the variance of this random variable x1? How would you find it?
So
the one who asked,
generally variance means we'll start from the mean and then we proceed with the variance, right?
Okay.
I'm trying to understand how do we compute the variance here for a distribution. So generally for a variance, we start with the mean and then from the mean we calculate the variance.
Okay, so you know the formula for variance, x minus expected value of x. You know this, right?
Yeah, for expected value. Yeah.
Okay, so we can simplify it like this. Like if you want to know how we obtain this from this, you can refer to week 9, 10 revision session. But yeah, after doing some simplification, you will get this thing. Okay. So here, if you notice, we need two things: expectation of x square and expectation of x, right? So what is expected value of x first?
P, sir.
It is 1 times p plus 0 times 1 minus p, right? So it is p. What is expected value of x square? It will be 1 square times p plus 0 square times 1 minus p, right?
Mhm.
Is this thing clear? Is this step clear?
Yep. Yes. Yeah.
Okay, so expected value of x square is p. So we got variance of x as p minus p squared, right? Which is nothing but p times 1 minus p. And recall, what is your binomial random variable? It's just the sum of n independent
Yeah.
Bernoulli random variables, right?
Mm.
So we know by property of variance, like if these all are independent, I can write it as their individual sums, right?
Yeah.
And each of these xi has the same variance because it has the same probability of success, right? So it's p times 1 minus p plus p times 1 minus p. I'm gonna add it some n times, right? So it comes out to be n times p 1 minus p. Is this thing clear?
Okay. It's a summation of all the variance.
Yeah.
Yeah.
Because all these are independent, right?
Okay.
Okay, moving to week 12. So, firstly, what is continuous random variable? Do you all know by now what is continuous
Sir,
random
I have a
variable?
doubt in 11.2.
11.2 activity,
Question
right?
number, yes. Question number 2.
Okay. Activity 11.2, right?
Yes.
Which question?
Question number 2, sir.
2. Okay. Okay, so how did you approach this one?
Sir, here we have a number of random variable is 5. So n is equals to 5. But sir, probability here they have given 0 and 1, and in between 0 to 1 they have given these probabilities. But sir, they ask find the value of p. So exactly what value we have to give for this p? Means for the which range we have to give?
Okay, so are you able to convert this PDF to PMF?
Yes, sir. We can.
You can. Okay, so what would be the probability x equals 0?
$1,024 divided by 2.
Okay, do everyone know how to convert
Yes, 1024
CDF?
by 3125.
Sir, can you please tell once again how to convert?
Okay, so here notice that Okay, let's do it that way. 1024 and 2304. Let's do on these two values for now. What was the other one? Okay, let's take something. Let's not bother about it. 0 for x less than 0. 1 and it takes value 1. Okay, so for what happens in case of discrete random variable is, okay, see, we know that it's gonna take some values only at some point, right? It will not take at all the points. It will only take values at some specific points, right? And we know that it follows binomial, and the maximum value it can take is 5, right? It can go up to 5. So in general, we are performing 5 trials, but we don't know what is probability of success. But we know what CDF is actually, it is given to us. So to convert into CDF, let's recall the plot for CDF. Used to plot. So see, for less than 0, it will remain 0, right? It will be 0 for all values of, right? But as soon as we reach 0, the probability becomes 1024 by 3125, right? And it will stay the same till we reaches the point 1. And as soon as we reaches the point 1, it again jumps to and reach at this point, which is, let's say, 2034 by 3125. So notice what happening is, as soon as your x reaches 1, it is 1024 by 3125. As soon as your x reaches 2, right, it got an increment of this much, right? But it is 2034 by something minus 1024 by this number. Okay. Are you getting the idea, like how we are obtaining it from the
Yes,
graph?
sir.
Yes, sir.
Let's, okay,
Sir, in that case, we have to do the subtraction of value and its previous means max value minus minimum value, right? So here you can see for the range 1 less than equal to x less than 2. Okay, so
Yeah.
here P of we have done 2034 divided by 3125 minus 1024 by 3125 in case of px equal to 2. In case of px equal to 2, right? Okay,
Yeah.
okay.
Okay. Is this thing clear how we are getting the PMF from the CDF? Or any doubt in this?
Sir, one silly question, sir. How the value came as 5? Means if
How the
we have
value
to start
okay.
n equal to 5.
See, okay. Yeah. See, we know that it follows binomial, right?
Yes.
What is the possible value your x can take? Maximum value.
Maximum value 0. Sorry, 5. 5,
right? And if you recall, x, like if you are, it's binomial, but it is denoting number of successes, right?
Yes, sir.
And maximum number of successes you can get is equal to number of trials you are doing.
Okay.
Right? If you're doing it 5 times, maximum you can get only 5 successes. So here the maximum possible value of x is nothing but the number of trials you are doing, which is n, right?
So we are ignoring, sir, first entry, right? X less than 0. So we don't need to consider that, right?
Yeah, it will always be there in CDF. It will always start from.
Sir, if it is x is equal to 3,
yeah,
we have to subtract from 2944 by 3125 minus the sum of the previous two, sir.
No, x is equals to 3. See at which point
Yes,
it is
at x is equal to 3.
No, not like
3104,
that.
right?
I mean, x is equal to 2.
X is equals to 2, yeah. 2944 minus this 2304.
Minus exactly the preceding or the sum of the two, sir?
Exactly
So
the
it will be sum of the two, no?
It will be sum of the two, sir.
It is already
The
sum.
sum of two. It is already sum, right? CDF means
Yeah, yeah.
it
Acha,
keeps
okay,
on
okay.
summing up.
So exactly the previous one is to be subtracted. Yeah.
Yeah.
Right, sir. Thank you.
So then what will be the value for x equals to 5?
X equal to 5, yeah, it will maximum reach to 1, right? X equal to 5 would be 1 minus exactly the preceding one, right? 1 minus 3124 by 3125, right? Is this clear how we are obtaining PMF?
Yes, sir.
Okay, so two things to take care of for such question to avoid calculation. Only one thing you can say. Take extreme values. Either take x equals 0 or x equal 5. Nothing else. Okay. Why? Because see, we know this value, right? It's 1024 by 3125. We know this value, right? Right? So what is probability x equals 0? It is like 5c0 p raised to the power 0 1 minus p raised to the power 5 minus 0, which is nothing but 1 minus p raised to the power 5 equals to 1024 by 3125. You can easily do the comparison. If you take this thing, probability x equals 5, it would come out to be p raised to the power 5, which is 1 by 3125. Simple calculation, right? But suppose if you take some other number, you take x equals 2. Calculation would be tougher. First, you need to compute 5c2 and see this is the expression you will get equal to some value. This, like, the equation will get more complicated. So to avoid the complex calculation, just stick to the extreme values. So you can easily solve any of this equation. You can solve, right? Both will give you the same answer for P. Is it clear? Or any doubt in this, anyone?
No, sir. Sir, you can continue for week 12. If anyone don't have any doubt.
Okay, let's move to week 12. Okay, so in week 12, okay. Do you recall what is continuous random variable?
Continuous is which is measurable. Means we cannot count in numbers. In the sense means, example is speed.
Which takes the values on an interval, sir?
Yeah. Okay. Okay, so you all know this. So it can take all the possible values, right? So I think we have discussed it and solved this also. But yeah, how do we find the probability? Suppose this is my curve. Okay, suppose this is 0.1. Okay, this is 0.2. That I think then, okay. Suppose my plot goes something like this. I'm going to drop it straight like this, this, and this. Okay. Let me look at this. Let's say it's 0.25, 0.5. This point. Okay. 0.25. So it is 0.75. This point. Okay. So how do we compute? Like, okay, these are the, let's say, your x is some continuous random variable which can take values in the interval 0.25 to 0.875. Okay. So how do you find the probability that your random variable takes the value less than or equal to 0.5? How do we find probability in case of continuous random variable?
Area under the curve.
Area under the curve, right? So for less than equal to 0.5, what would be the area?
0.25.
0.25 into 1.
This cubicle, right? This rectangular part. So it would be 0.25. You can consider it to be breadth and length is 1. So it's 0.25. Okay. Now, if I ask less than 0.5, not less than equal to 0.5, what would be the answer in that case?
Same.
Same, right? Because if I include this line or not, it barely matters because area of a line is 0, right? You all know that. If I include this line or not, it won't affect my answer. So for continuous random variable, probability at a point is always 0. This is one of the important things to keep in mind.
Can we
It's
do
continuous
something like
random.
can we do something like 1 minus p of x greater than or equal to 0.
So you can do like that also. Both will give you the same answer. You can do it like that also. Okay.
That will be 0.875 minus 0.5 will be 0.375 into 2, right? 0.375 into 2, 0.5, 0.75.
Yeah, 1 minus 0.75, right? Okay, so are you getting it? Like for continuous, how do we compute the probabilities?
So at a particular point, the probability is 0. Like within the interval, at a particular point, the probability is 0 for continuous.
Yeah, because okay, how many points are there in this interval? How many points would be there? Can you count?
Oh no, infinite.
Infinite, right? Or those who don't know infinite, it's a very large, right? Large number of points. Okay, we are interested in only 1 point, exactly 0.50, right?
Yes.
So your favorable cases are only 1. Total cases are very large.
Okay.
Right? So 1 upon very large number, it's 0, right?
Yeah, tends to
You can
0.
also think it something like that. Okay, so yeah. So what's the conditions for? Like here you can see that the value of PDF, it's going greater than 1 as well. So don't, it's not the condition of probability getting violated because here the condition is like that area under the curve should be 1. Okay. So you add up all the area under the curve, it should be 1, and your fx can be any value greater than or equal to 0. It should not go below this x-axis. It should be above it only. And it can go beyond 1 as well, as long as area under the curve remains 1. Okay. Is this thing clear? Any doubt in this, anyone?
Clear.
Okay, so CT mock is shifted to 10:30 to 11:30. Okay, so you all can do it. Okay, is this thing clear till now?
Yes, sir.
So moving further in continuous, we have only 2 distributions covered for the part of stats 1. It's uniform distribution and exponential distribution. Does anyone know what is uniform distribution? Like we have studied one in discrete as well.
It is equally distributed.
Constant.
Distributed. Okay, so it's like my fx will take some constant value, let's say c, for the range. Let's say if x is some continuous variable, right, in the range A to B. So it will take the same, like my PDF will take the same value, some constant C. So suppose this is your A, this is your B. So A is the lower point, B is the upper point. It is gonna take some constant value C. You start from here, will keep on going till here, right? So what is this value C actually equals to? We know that area under the curve should be 1, right? Which means this complete area should be 1, right? So if you notice, this is your length, this is your breadth of rectangle, right? So we know area should be 1. What does it mean? That C times
B
B
minus
minus A
A.
should be 1. So in general, our constant is generally B minus A. So if I say that X follows uniform in the range 10 to 20, you must be able to identify that your PDF is 1 over 20 minus 10, which is 1 over 10 in this given range, right? Is this thing clear? Or any doubt till now, anyone?
Sir, 1/10 is the CDF.
PDF. It's a PDF. Because if your C is equals to 1 by 10, A is equals to 10, B is equals to 20, then this area under the curve would be 1 in that case, right? Okay, so any doubt till now, anyone?
So, sir, we can say that the here FX PDF is probability under this rectangle, right? 1 upon
Probability
B
under this
minus A.
rectangle should be 1. So what value should this C take that this area becomes 1? It is 1 over B
Okay.
minus A, right? In this range. Okay, so yeah, how do we compute the CDF? CDF means, I'm talking about only the uniform random variable for now. It means that it takes the value less than or equal to some x, right? So recall here. So this point, as we know, is 1 over B minus A for now. We are aware of it. This is point A, this is point B, right? So my uniform random, it has PDF something like this, right? It's a straight line. Okay. So suppose the point I'm interested in is X. It lies somewhat here. It can be any point in between A and B, right? So you want to compute the probability that my random variable will take the value less than this X. It means I need to compute this complete area, right? This area is what we needed to compute, right? This is my
Yes,
region
sir.
X less than equal to X, right? Okay. So what would be the area? So again, it is a rectangle, you can see. So my length is 1 over B minus A. What would be the breadth?
X minus A.
X minus A.
X minus A, right? So your probability that would take less than equal to X would be area under the curve, which is length into breadth. It is X minus A upon B minus A. You can also remember this formula, or you can, in case you forget, you can derive it like this as well. Is this clear, everyone? Any doubt in uniform distribution, anyone?
No, sir.
Here, sir.
No, sir.
Okay, suppose, let's quickly do some examples. Suppose your X is uniformly distributed between minus 10 to 10.
Sir, one more question. In exam, in question, so it will be mentioned,
Yeah.
right? Is it uniformly or exponentially?
Yeah.
Or do we need to
For
derive
now,
it?
it would be mentioned, but as you proceed further, like it won't be always given to you. For this coursework, yeah, it would be mentioned in most of the cases. Okay,
Okay.
okay, so let's say you're just follow uniform. Let's say minus 1 to 1. Okay. So what would be the PDF in that case?
One upon two.
Half.
1/2, right? Okay. What is the probability that it will take the value less than 0?
1/4.
1/4. Okay, so it would be 0 minus a upon 1/4. Okay, it's coming out to be 1/2, I think. Right? Plugging in the formula, right? X minus a, x is 0, a is minus 1 upon b minus a, b is 1 and a is minus 1. It's 1/2. Is this clear? Or any doubt
So
on
no,
this?
sir. Can
Anyone?
you just repeat it, sir?
Okay, so what will be your like what will be your CDF at 0.0 for uniform distribution? Okay, let's just visualize it. So it follows uniform from it follows uniform from this -1 to 1, right? So your plot would be something like this. And we know this point is 1/2, right? This point over here. So to find that it takes the value less than or equal to 0, we need to compute this area only, right? This rectangular area, right?
Yes, sir.
So what is the length? It is 1,
1.
right? Okay, what is breadth?
Half.
Half. 1/2, right?
But it can be negative.
But can be negative?
The area can be
Value of
negative.
a and b can be negative. Yeah. But your probability would always be greater than 0. Greater than or equal to 0. Okay. Okay. If you want to go by formula, so formula which we obtained was this, right? So what is your x here? X is 0, right? A is -1. B is 1 and A is again -1, right? So it's 1/2. So you can either go by this or this, possibly the same answer. Okay. What is the probability that your random variable will take the value 0?
0.
0.
0.
0, right? Don't compute this thing. So, but like many students make mistake is we ask the probability at the point 0 and they compute this CDF at point 0. So be careful with the question statements. Okay. Any doubt in the uniform distribution, anyone, before we proceed to exponential?
Then what does it mean half? F of x.
F of x.
Half. What does it mean?
What does it mean? Okay, it means that the point at y-axis for the curve would be at 1/2. This is the point. This is 1/2, right? Your line of curve will pass through it throughout. It will remain 1/2 in this range, -1 to 1. It will remain 1/2 throughout the range.
It is
That's
a
what you are going
probability
to.
or
It's not the probability, it's the curve, probability density function curve. For probability, we compute area under this curve.
okay.
Sir, graded assignment week 12 question number 2, which is related to this cumulative distribution.
Okay. Grade assignment 12, right?
Yes.
Okay, which question? Second, right?
Yeah, second one.
Okay, it is continuous. Okay, so yeah, how would you compute it?
So actually, I use the formula kx square equal to b square minus a square by 2. And there I got the value of k is 0.5. And after that, I use that one. Okay, I think I had done something wrong in computation. Like p equals to 0.5 greater than equal and x than 0.8, and then I use that formula which is given in the hint.
Okay. Okay. So let me write down. So what you're saying is, what you do is, we know that our PDF is kx square within the range 0 to 1, right?
Right.
So what you do is you integrated 0 to 1 kx square, which will give us the area under the curve, right?
Yeah.
And we know that it should be equal to 1 because we are taking complete range, right?
Mm-hmm.
Then you use the formula, so it gives you the value something like this, right?
So this is not uniform.
But
No, it is not uniform.
yeah.
The kx square.
It is not uniform. Yeah. Uniform, it takes only the constant value. If it had been only k, then it has been uniform. But it is x square as well.
Then we can say that k into 1.
As it
Yeah,
is not,
k into 1.
use that
Yeah, not you.
can we use the square by 2 formula?
Which formula?
B square minus a square by 2.
B square minus a square by 2. How would we use that formula? Because it's okay. So let me elaborate on it a bit. Okay, see, so what's happening over here is, okay, do you have like in aware of integration in some sense? Like, what does integration give us?
Mm-hmm.
Okay, so this is your curve, right? So it would be some k times x square, it would go, I think. Something like this, it should go, right? Your curve, it will go something like this, right? For x square, k times x square, if you draw. And it
Yeah.
will go till the range 0 to 1, right?
Yeah.
And we know that area under the curve should be 1. It's not
Yeah.
uniform. We can see it's some random curve going upward, right? And it will uniform. For uniform, we have only straight lines, right? Okay, so how do we find this area? So to compute this area, what we do is we integrate over the range. So our lower is 0, upper is 1,
Mm-hmm.
kx square dx. It
Right.
gives us the area under the curve, okay?
Yes.
And we know that this area should be equal to 1.
Yeah.
Now, even if you don't know integration, the formula is given to you as a hint. It is k times this upper limit cube minus lower limit cube whole upon 3. It should be equal to 1, right?
Yeah.
So your k is 3.
Okay.
So in general, your PDF comes out to be 3 times x square, where x is in the range 0 to 1. Right? Now we
Mm-hmm.
need to compute that it lies between 0.5 and 0.8, right?
Yeah.
Which means I need to focus on, let's say this is 0.5, this is 0.8. I need to focus on only this area under the curve, right?
Exactly.
So it means I will integrate for this area my PDF, right?
Yes.
This curve. So again, the formula is given to you, so it would be 0.8 cube minus 0.5 cube whole upon 3. So it comes out to be 0.8 cube minus 0.5 cube.
Okay, got it. I did.
Okay.
So this is exponentially distributed.
Not exponential. It is some quadratic
Okay.
function going on. We will study exponential now. Okay. Any doubt? Anyone
Sir,
else?
there is a, in the same graded assignment, question number 4.
Question number 4. Okay. Okay. Question number 4. Okay. What should be the answer according to you?
It is 0.
Yeah, why 0?
Sir, it's just a common sense, but is there any mathematical thing to
Yeah,
solve
there is
this
mathematics we just
question?
did, right? Okay, so you might have some different values for my values. It's going something like this. Like it follows uniform from point 1 to 7, right? I need to find the probability exactly at 0.5, right? Exactly at this point, right? Which means area under the curve would be this line only, right?
Yes, sir.
Yes, sir.
What is the area of this line? Zero, right?
0.
0.
Area,
Yes.
line has no area. So one way to think of it is like this. Okay? Another way you can approach is between 1 p.m. to 7 p.m. How many possible values you can have? You can have
1,
1
2.
p.m. 0
Infinite.
minutes 01 second, right?
Sir, we can say it is infinite. Infinite.
Yeah, yeah.
Infinite, right? Very large, you can see. And so your total number of cases are very large, right? Your favorable is only one, which is exactly 5 p.m., right?
Yes.
Right. So probability is 1 over like favorable upon total, right? So 1 upon very large number, which is 0, right?
Almost 0. Yeah.
Yeah. So that's why it's 0. Is it clear now?
Yes, sir. Thank you.
Okay. So yeah, moving to exponential distribution. So your exponential distribution, like I won't go much into the derivation part for now. Okay. So exponential distribution, your PDF is given by some lambda times e raised to the power minus lambda x. Few conditions. Your lambda should always be greater than 0, strictly greater than 0. Keep this thing in mind, it should be strictly greater than 0. And your random variable x, it can take any value greater than or equal to 0. It can take the value 0 as well. So whenever you see some PDF of this format, you can directly say that your x follows exponential with parameter lambda, or if it is given that this things follows exponential distribution, so you must be able to identify that yeah, this is gonna be the PDF used for this random variable. Okay, so in this, how do we compute the CDF? Like we know PDF, like how we get the CDF. So CDF is all the values less than or equal to that specific number x, right? So for that also we do some integration and we arrive at, but I assuming that you are not aware of integration, so you can directly remember this part. Probability x less than equal to x or CDF at a point x, it is this thing. And is this thing clear? These two?
So no, sir. Can you please repeat it?
Sir, this is clear. But sir, why I got confused, sir. We have to use e raised to the above formula and 1 minus e raised to minus lambda x formula. Sir, I got confusion here. 1 minus and e raised to. Sir, how I can approach or how I can solve this, sir?
I didn't follow when you explained like how you got the second formula. Can you explain it once again?
Second formula, we have to do some integration and all. So I'm not going much into derivation, but it would be like you are integrating. You're finding the area under the curve, right? For this thing.
Yeah, I mean,
So
like you
on
were saying,
solving it,
like
we get this.
we not knowing integration, you're like putting it in simple terms. So I thought you explained
Yeah,
something,
I
but I
said
didn't
you're
get it
not.
exactly.
Yeah, you're not aware of integration, so I'm not going into that
Okay,
derivation
okay,
part. You
okay,
can
okay,
study.
get it.
Okay, so this is CDF, but suppose you want to find probability x greater than x. What will you do in this case? How will you compute this?
1
2
minus
2
x is
plus e
less
to the power
than
minus
equal to x.
1
minus
minus
1
CDF you
minus.
get.
Yes.
So plugging in the value of CDF, we get e raised to the power minus lambda x, right? Okay, now just for a question, let's say your x follows exponential with parameter 10. Find the probability that your x takes the value greater than 20. What would be the answer?
1 minus probability x less than 20.
That e to the power minus 10.
E to the minus 10. Okay. Anyone else? What would be the answer? The formula is written here, right? Probability is greater than x.
E to the power minus
To the power of
200.
minus 200.
So
sir.
minus 200. So.
Minus 200, right?
Yes, sir.
Okay. What is the probability that your random variable x takes the value less than 20?
1 minus e to
1
the power
minus
minus
e power
200.
minus 200.
It would still be the same, right? Is this thing clear? I think the formula which you were referring are these two, right? You are getting confused between these two formula. So the second one is for x greater than some constant and the first one is for less than some constant.
So same formula for less than and less than or equal to both.
Yeah, because see, x less than equal to 20, right? I can write it as less than 20 plus at this point 20, right?
Yes, sir.
What is
Equal
this
to 20.
probability?
0.
0. So these two are same, right?
Okay, sir. Understood, sir. Thank you.
Okay.
Sir, what
Anyone
does the
any doubt till
parameter
now?
mean?
Yeah. Parameter means it tells you something about the distribution. Like in case of binomial distribution, it tells you about number of trials and the probability of success, right?
Yes.
In case of uniform distribution, it tells you about lower limit and upper limit of the variable, right?
Yes.
Similarly, in case of exponential, it tells you about this how much you want to scale your exponential curve. It tells you about it. Okay.
Okay.
So, any doubt till now? Anyone else?
No
No,
doubt, sir.
sir.
But can you give some questions to practice, sir?
Yeah, we will come to questions. Before that, I think two things we have skipped.
Okay, sir.
That
Thank
is,
you.
if x sphere follows uniform a comma b, then what is the expected value of x?
A plus b by 2.
A plus b by 2, sir.
A plus b by 2, right? So I'm not going again into the proof because it will involve integration and I'm assuming most of you are not aware of it. So you can just try to memorize it a bit.
b minus a whole
As
square
you
by
move to
12.
stats 2, you will know how we are doing it. Yeah, b minus a whole square by 12. And if your x follows exponential distribution with parameter lambda, its mean would be
1 by lambda.
1 by lambda square variance.
1 by lambda square. Okay. Great. Okay, so yeah, let's do some question. Okay, another common mistake part. Okay, let's do it. Suppose, let's say, okay. Okay, suppose something is distributed. Let's see. Something. Okay, suppose we are doing something, let's say, suppose we are doing some experiment, okay? can be anything like anything you can think of, and it is exponentially distributed. With, let's say, mean 10, and you need to find the probability that x is, let's say, greater than equal to 10. So how would you do it? Anyone?
Lambda is 1 by 10.
Lambda is 1 by 10, okay.
So e power minus 1.
One minus e power minus 1.
Sir, mean 10 means we can.
E to the power minus 1, sir, answer.
Yes.
Yeah, e raised to the minus 1. So yeah, the important
E
thing to
power
keep in
minus
mind,
1.
you are given mean here. So you
Mean is
must
1
be
by
able to
lambda.
interpret, yeah, that lambda would be inverse of that. So what the common mistake here is when people take lambda is equal to 10 and then compute. So it will be, that's one of the common mistakes we do. Okay, I think we're done with all the concepts. Any doubt in any of the questions of the assignments? Anyone?
Sir, what is uncertain Bernoulli trial?
A certain point, I think we just discussed. You joined late, right?
No, sir. I know it clear.
Okay. Uncertain Bernoulli trial is the Bernoulli trial which has the maximum variance. Okay, so we know variance of Bernoulli trial. It's okay. What is the variance of Bernoulli trial? You know?
So just you explain, sir. I understand later on.
Okay, it's p times 1 minus p. So this value will be maximum when p is equals to half. So whenever your probability of success would be half, it is most uncertain Bernoulli trial.
Graded assignment.
Okay.
Sir, graded assignment 12, 5, 6, 7 from the. Yes.
Graded assignment of 5, 6, 7. Okay. I want to solve the complete assignment. Let's see. Graded assignment 12, 5, 6, 7. Okay, how did you approach the question number 5?
I didn't get that for the question number 5.
Okay, let's go line by line. The length of time for one person, okay, the time it's going to take to serve one person, it's exponentially distributed with expected time 2 minutes. So what is the information you are able to grasp from here?
Lambda is 1 by 2.
Lambda equals to 2.
Lambda is equal to 1 by 2. E of x is equal to 2.
Right. It's expected time. So that's the common mistake I was just talking about. So it's mean given to you, right? Mean is 1 by lambda. It means 1 by lambda is 2. So lambda is 1 by 2, right?
Yes.
Okay. Next it says is that 5 person arrived at restaurant. Then what is the probability? At least 2 of them will be served in more than 7 minutes. Okay. So let's, okay, it's kind of gonna get mixed up. But let's do this one, I think. Okay. So, okay, let's talk about one person only, right? One person. So it follows exponential with parameter 1 by 2, right?
Mm-hmm.
And I'm interested in that serving will take more than 7 minutes, right?
Right.
Okay, so what is the probability that x is greater than 7?
E to the power minus lambda x. Lambda is half.
Minus 3.5, right? And for like less than equal to 7, it would be 1 minus e to the minus 3.5, right? So we also know that for each person it's gonna be same, right? For every person it's gonna be same, right?
Yeah.
And it is mentioned in the question that we are serving everyone independent of each other also, right?
Yes.
Okay, and we are doing it 5 times. So are you able to link it with something? Suppose this is my Bernoulli
Binomial.
trial. This is my Bernoulli trial, right? My success is that x takes the value greater than 7. Failure is less than equal to 7. Probability of success is e raised to the minus 3.5, right? Are you able to see my whiteboard?
Yes.
Okay. So probability of success is e raised to the minus 3.5. Probability of failure is this, right?
Yes.
So in some sense, it's taking value 1 with probability this, value 0 with this probability, right? So now I'm doing this Bernoulli trial 5 times. So it becomes binomial, right?
Okay,
All
got
3 conditions are satisfied. P is constant, independent. I know it's gonna be 5 times. So 5 and probability of success. So now it's binomial. You can compute
yes.
whatever the required part, right?
Yeah.
So it's kind of link of exponential to binomial. Okay.
Question number
Whenever
6.
whenever you are given information that independently it's happening, there must be something major role it's gonna play. So be careful if it's mentioned. Okay.
So, excuse me, sir.
Yeah.
Sir, can you explain how to calculate the answer for question 7 in activity 12.3?
Yeah, we'll come to that. Let's
Sorry for the interruption, but in the same question, if it is not independent, then how can we approach, sir?
if it's not independent on how we won't be able to approach. That's why I'm saying if it's mentioned independent, it has a major significant role to play. If
Okay,
it
sir.
not if it is mentioned, it means in some sense the question is unsolvable if it's not independent. That's why it's deliberately mentioned in the brackets, right?
Okay, sir.
But sir, in the question, what is the role of this? At least 2 of them will be served in more than 7 minutes.
And that's you have to find it. You will get at least 2 successes of the 5. Your success is that you are serving in more than 7 minutes, right?
Right.
So what are the chances of getting at least 2 success in the 5 trials?
R is 2,
Something we
right?
have to do. Yeah, at least 2 success, right?
Okay, got it.
Okay, moving for the question number 6. Okay, question number 6. How did you approach this one?
I didn't do it and I didn't get it.
Okay, so I think okay, after you know how to find probability for a continuous random variable.
Yeah.
We find area under the curve, right?
Right.
Okay, so let's do this. 0 to 1 by 2x. Let me note it down first. Okay, let's do this. So your PDF is given like this, right? 0.2x for the region 0 to 1, right? And then it's 0.2 for the region 1 to 2. Then it's 0.2x minus 0.2 for the region 2 to 3, right?
Yes.
And so on. So now we need to find the probability that it lies between 0 to 2.5.
Yeah.
So you know what is 0.2x? It's gonna be some straight line, right?
Yes.
It's gonna be subtracted. So at point 0 it would be 0, at point 1 it would be 0.2, right? It's 0.2, right? After that, till 0.2 it's gonna remain the same.
Yes.
Right? Okay. After that, it's again gonna be some line, right? Till 0.3. So if you notice at 0.2, it would be 0.2, right? 0.2 into 2 minus 0.2. It's gonna be 0.2, right? So this condition is satisfied. At 0.3, it's gonna be 0.4, right?
Okay.
So again, it's gonna take some hike and be here at 0.3.
Yes, yes.
Yes. So now I need to find the probability that my random variable x takes value 0 to, I think, 2.5, right? So to compute that, I need to find the area under the curve.
Yes.
Till this point,
Yes.
2.5.
Half of
So 0,
the 2 and
yeah,
3.
it's the rectangle, it's the triangle, right? Area of triangle is half into breadth into height, right? Plus area of this
Rectangle.
rectangle, right? It's gonna be 1 into 0.2. Then in the last, it's the trapezium, right? You can do it. You will get the answer, right?
Yeah, I got it now.
Okay. Okay, moving further. Question number 7. Okay, how would you do this? I think we did the similar one. Okay. So in a certain exhibition, the time for standard deviation is 70 minutes. Okay, what is the standard deviation of exponential distribution?
Root of variance, like
So what it's
1 by lambda square.
so
by 1
1 by lambda.
1 by lambda.
1 by lambda, right? So lambda is 1 by 17, right?
Right.
Okay, so what will be the expected time for two visitors to arrive if one comes after other? Okay, so again, it's some independent thing mentioned to you,
Yes.
right? So how will you find, like, are you able to grasp like what it is telling? What will be the, what it is asked in the question? What will be the expected time for two visitors?
So it is like E of x1 plus x2, where x
E
is
of x2.
Yeah, right. X1 is the time of first visitor, x2 is the time of second visitor. So expected value of x1 plus x2, right?
Yes.
But it is 1 by 17 plus 1 by 17, right?
Okay.
Is it? No, I think 1 by 17. Okay.
That's what I
Hold it
opted,
right.
sir. 2 by 17.
C answers.
Okay. Exhibition 2 comes one after the other.
No, it would be 2 into 17 because standard deviation is 1 by lambda and expected time is also 1 by lambda. So expected time
Yeah.
for x1 is 17 and for
Yeah.
x2 is also 17. So it is 2 into 17.
Yeah, great. Got it, right? So these are some common mistakes. So like even if I am not writing down, I'm getting confused. So, and you get such questions in exam, please write and find the value of lambda at least before proceeding further. Okay.
Okay, sir. Thank you.
Okay. Someone was saying activity. Which activity?
Activity 12.3 7th question.
Activity 12.3 7th question. Okay, so your CT mock is changed, right? Did anyone check? It's 10:30 to 11:30. Is it done or?
Haven't get any kind of email.
Not email, just check the portal. Is it changed or?
No, sir. It's showing still 9 p.m. to 10:15 p.m.
Okay.
Yeah,
it
but
failed.
under mock test quizzes, it's not available actually.
It's not available, right?
Yes, sir.
Yeah, so maybe they will
Yeah,
reschedule
it
the
will get
announcement.
released at, yeah.
Sir, excuse me, sir. What will be the weightage for 1 to 4 weeks, sir?
1 to 8 will be
1 to 8 would be 30, yeah.
30.
1 to 8 would be 30. Okay.
Yeah.
Thanks.
The major focus is going to be 9 to 12 only, because this distribution and random variable is what you will start stats 2 with.
Oh, right, sir.
Okay, yeah, so this question, right? 10, 12, 14, 16, 18. Okay. So how did you approach this one?
So I wanted to know the seventh question. I mean, I'm not able to understand how to calculate the answer for seventh.
Okay, we will come to that as well. First two parts we were able to do, right?
Yeah.
Should focus on drawing straight lines. So this is point 10, this is point 12,
16, 18.
16, 18. Okay, so what we need to find in the seventh question?
11 to 15, for 11, between 10 to 11 to 14. 11 to 14,
11
I
to
guess.
Okay, yeah. Your major concern is this 11 point anyway, right? So it's a 14. 11 to 14 means this area, right?
1 minute, sir. Yes, sir.
Okay, so what is this point we know, right? It's 1 by 6, right? If I
Yeah,
remember.
that can be done to 2 into 1 by 6, but 11 to 12 is what
Yeah, that's your
formula can
major
I use
concern,
for
right?
that?
This
Yeah.
point you need to find, right?
Yeah.
How would you find this line?
Do I do
So
1 by 6 by 2? Like,
no, not like it might get through in this case, but not always. So see, this point is what 10 comma 0, right?
yeah.
This point is, I think, 12 comma 1 by
12
6.
comma 1 by 6. Okay.
You know how to find the equation of line?
What am I finding here? Like median, I mean like midpoint? I don't think it's midpoint.
Yeah. You know how to find equation of line?
Yeah, I do.
Given 2 points, you can find equation of line, right?
Yeah, we
In
can.
maths 1, you might decide.
Yeah, equation we can find. Yeah.
Okay, so what's this? Okay, suppose this is your x1 comma y1.
Okay.
This is your
Yeah.
x2 comma y2. So it's y minus 0, x minus 10 equals y2 1 by 6 minus 0. x2 is, I think, 12 minus 10, right?
Yeah.
Okay, so y over x minus 10 is 1 over 6 into 1 over 2, right?
Yeah.
Okay, so y is equals to x minus 10 by 12, right?
Yeah.
Okay, we need to find this point, right? At this point would be 11 comma some y.
Oh,
This
okay.
point
Yeah.
is on this line.
Okay, we
So
substitute x as 11 there and
okay,
1 by 12.
y is equals to, you have this point. Now you can find the area, right?
Yeah, I find out like the square or rectangle and then the above triangle.
This trapezium and this rectangle you can go.
Yeah, I mean like I don't know the area formula for trapezium, so I'm going for
Yeah,
square
any
or
area you find.
square or rectangle, then above triangle. Add it up.
Yeah.
So is there like a direct formula for trapezium?
Yeah, there
Yeah,
is.
here it is. It's
I
like
guess a plus b by 2 into height, something, I don't know. But this
half
trapezium is
times
different
height.
actually. Because this trapezium is different than the whole picture of the graph.
No, see, this is trapezium, right? So what are your parallel lines?
Okay. Yeah. Parallel lines are okay. 11 by
The-
1, 11 1 by
these-
12 and 12 1 by 6 are parallel lines. Okay.
Yeah, these two are your parallel lines, right?
Okay, yeah, right.
So
And
formula for
height is
trapezium
1.
is half into distance between the parallel lines, it is 1, right?
Yeah.
Into sum of parallel lines. So this length is 1 by 6. This
That is
length
1
is
by
1 by
12.
12. So you can directly compute this complete area.
Yeah. 7 by 12. 7 by
It's gonna be 1
24.
by 2 into 3 by
7
12.
by 24.
1 by 8, I think. You can check, might be wrong. But the approach is clear, right?
Yeah. Yes.
How? Okay. Okay. Anyone, anything else?
Sir, one question.
Your voice is.
The maximum. What will be the maximum? In maths, sir said that there will be a maximum in the symmetry.
Your
Is there any
voice is. There
possibility?
is a lot of disturbance coming from the back.
Hello.
Okay.
Now it is
One more
audible.
thing. Yeah, now it's audible. Yeah.
Okay. Sir, what will be the max mark for particular question? Means in maths we got in quiz 2 we got highest mark was 7. So and in stats we saw 5. So in
Yeah,
term
in
also it
stats
will be
it's
5
usually
or
5. Yeah, in stats it's usually
okay
5.
okay okay.
Yeah, and
So
one thing. Yeah,
we can say
tomorrow.
in.
Yeah, yeah. Tomorrow 2 mocks will be released for stats 1. Okay, one would be the time mock, which will be of similar pattern to your Antam exam, and one would be practice mock, which has some practice question, like a collection of practice question would be there. Okay, so the time mock would be similar to the Antam pattern, where the practice mock it's just random practice question. Its pattern has nothing to be linked with Antam, but yeah, you can still practice more question if you want from mock practice. Okay. And
Sir,
time mock will
Sir,
be
at what
available
time
till.
it will be released?
It will release tomorrow morning. Okay, and it will stay till like 1 hour before the mock session.
Okay.
sir,
Friday 6 or
Sir,
7.
on Friday session, which mock will be discussed, sir? Then in Friday session.
Both will be discussed, but major focus will be on time mock.
Okay.
sir, can I questions from
Yeah,
line?
yeah, sure.
So actually, I got stuck in activity 9.2, question numbers 3 and 4.
Activity 9.2, question 3 and 4. Okay, how did you approach this one? Okay, how did you approach this one? There are 10 blue, 5 red. Okay, we did similar examples today. A ball is thrown, put it back. Okay, we are doing a with replacement, right?
Yes.
Okay. How many draws will result in x equals 1? But does x equal 1 means? What is x equals 1?
Both are same color.
Both are same color. So either I draw both blue balls or both red balls, right?
Yeah.
In how many ways I can draw 2 blue balls?
15.
How much?
No.
Okay, in the first trial, but in how many ways can I draw blue ball? In first
Yeah.
draw, 10, right?
Yeah.
After drawing, I am putting it back. So my bag again has 10 blue and 5 red. For
Right.
second, how many ways I can draw blue ball?
Again 10.
Again 10, right? So in total, there are 10 into 10 ways to draw 2 blue balls, right? Okay. So there is some bag, 10 blue and 5 red, right?
Yes.
So 2 blue balls. What does it mean? It means at the first I should get blue, at the second I should get blue, right?
Yeah.
So in how many ways I can get blue in the first? It's 10, right? And in the second also I can get in 10 ways because any of the 10 I can draw, right?
Yeah.
And 2 red balls, like in the first I can draw any of the 5 red balls, right? Then I'm doing it with replacement, so again I can draw any of the red balls in the second draw. So x equals 1 means in how many ways I can draw both balls of same color. So either 2 blue or 2 red.
Okay.
Okay.
So if it is given
One after
without
another.
replacement,
If it's given with replacement.
I
Without
thought
replacement, you're saying.
without replacement.
So without replacement, at the first you can draw any of the 10 blue, right?
90. 10 into 9.
Second you have 1 9. So for
90
2
plus
blue it would
20.
be 90. Yeah, and for 2 red it would be 5 times 4. So it would be
And
110.
for x equal to 0,
X equals to 0. Okay, what does x equal to 0 denote? Let me check.
All different color.
Both also different. You have to make cases. First blue, second red, first red, second blue. Right.
okay, sir.
Okay. Anyone, anything else?
Sir,
Sir,
week
more question.
12.3, 3 and 4.
Sir, week 11.
Question
Okay,
number.
one by one, one by one, one by one. Which one first?
Sir, week 11.
Week 11, okay.
Activity 11.3, question number 2.
Question number 2. From the following.
Yes, sir.
Okay.
How we choose, sir, this is a left skewed or a right skewed from this point, like binomial n comma p?
It is covered in the lectures, right? You
Yes.
know when p is less than 0.5, it would be. I think it's p is less than 0.5, so it will shift something towards right.
Less
Left
than
skewed.
Less than
0.5, it is
0.5.
right skewed, sir.
Right skewed. Okay. Yeah. So if it's less than 0.5, it's right skewed. If it's
Greater than left, then if it is equal, symmetric.
Yeah.
equal symmetric. But if your number of trials becomes large, it would be symmetric. Large means greater
So
than
B
30.
and C, sir.
Yes, yes.
So here your number of
B
trials
and
are greater
C.
than 30. So yeah, it will be symmetric. And here number of trials are small, like less than 30. So and p is less than 0.5, so it would be right skewed.
Right skewed.
Okay.
Sir, can you please, what does the 30 mean, sir?
If its number of trials are greater than 30, it means your n is large.
Okay, so 30 is a
In
limit, right?
statistical, yeah, in statistics, 30 greater than 30 is large. So something like that.
Okay, sir.
Sir, in the in 9.2, the question number 4.
9.2 question number 4. Okay. Okay. How did you approach this one? Okay, what does your random variable x denote?
Zeros and number of binaries.
Length of
Length
code,
of
right?
code.
What is the length for A?
0.
1, right? Length.
Oh,
And it is
okay,
number
1.
of character. For B, it's 2, right? For
Yeah.
C and D, it's 3.
Yeah.
So you need to find the probability that your x is 3. It means either it is C or D, right?
Yes.
Because only these two have length 3. And we know both have probability of 1 by 8. So 1 by 8 plus 1 by 8. Right?
Okay. Okay.
Clear, right?
Excuse me, sir.
Yeah.
Sir, I just checked my hall ticket. I'm
Okay.
able to appear for the both in-term paper, I mean CT and Stats 1. But in hall ticket, it's only CT is available.
Only the forenoon
Yeah.
hall ticket has been made available as of now.
Yeah. You will get
That is why
stats 1
Stats 1 is in AN.
afternoon shift.
Sir, week 12.3.
12.3, okay.
Yeah,
3
thank you,
and
sir.
4.
Okay, let's consider it as last question because I think you got mock in 9 minutes starting. Question 3 and 4. Remaining we will discuss next session. 3 and 4. Okay, how did you approach this one?
Sir, I found the second question, but
Okay.
a
Third
bit
question means 0 to
confusion
1, right?
during 3 and 4.
You need 0 to 1 you find, right? 0 to 1 means you need to find the area of curve from point 0 to 1, right? Area under the curve from 0 to 1.
Yes, sir.
So it would be, you can divide it into two parts, right? If I put line from here, it will be two rectangles, right? Are you able to visualize?
Yes, sir. Yeah. Yes.
So find for the area, but will be the area of first triangle, first rectangle, 0.5 into 0.5, right?
0.5. 0.25.
For sec, and for second rectangle, it would be 1 into
1 into
0.5, right?
1.
1 into 0.5. Second rectangle, this one, right? 0.5 to
Yes.
1 would
Yes.
be the breadth.
Yeah. Yeah.
Okay.
Yes. Correct.
And for similarly for the fourth one, you can find the area between 0 to 1.5, area under the curve, right?
Yes, sir. Thank you. Got it.
Okay, anything else? I think we still have time to discuss one or two more questions.
Hello, sir. Will you share these notes with us?
So one question, 9.1 action, question 9, activity 9.1, 9. If it is already done, then let me know, I'll look it up. Activity 9.1.
Activity 9.1, question 9,
Question
right?
9. Question number 9.
It's not done, I think. Okay, let me see if I can go this. Yeah, okay. How did you approach this one?
So my approach was right. Find if for x is equal to 0, which means he has not made any sale.
Yeah.
Okay. So it will be 90 by 100 into 90 by 100 into 90 by 100.
Yeah. Good enough. Yeah.
Okay. Oh.
Okay. But what would be for x equals 1?
For x is equal to 1, one person should be buying the policy. Two people should not buy the policy, which will be for either the first person or the second person or the third person. That will be 10 by 100 into 81 by 10 by 100 into 81, 9 by 100 into 9 by 10 into 9 by 10 plus
And
that will
yeah,
be
I
done
got your
thrice.
approach. Yeah. So another piece of advice, please, read the question statements carefully. Okay, read this line and then will your answer change?
Yes, definitely. Because if the first person buys, it will be 1 by 10 and then he's done. If the second person buys, it will be 90 by 100 into 10 by 100.
Yeah.
The third person buys, it will be 90 by 100 into 90 by 100 into 10 by 100. Okay.
Right? Okay.
Okay.
Sir,
Anything else? Yeah.
can we find this PDF, sir?
Can we find PDF for this?
Means this PDF, these notes, sir.
It's written
These
on
revision
whiteboard.
notes.
So you can, like, we will, in YouTube description, we will add at what time we discuss which concept, so you can directly go to that timestamp and look at it. Okay. In every YouTube description video, we are adding this timestamp, so you can directly go and click on, like, directly go to that timestamp and watch video. So,
Okay.
okay. Okay, guys, I think we can close for today. That's the last session for this term by me. Okay. Hopefully, you will clear wicket to stats too. Okay. Thank you, everyone.
Thank you, sir.
Thank you so much, sir.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Yeah, thank you. All the best for you.
Thank you, sir.